Hello everyone. Today I will discuss how I build, validate, and optimize my classifier for the stroke prediction dataset. So key questions I will address are: is there a function classifier? Has a classifier's performance been appropriately validated? What validation strategy did I use to assess and improve model fit? Let's get started. So the first question is a function classifier present? Yes, I built a fully function classifier using PyCard and machine learning techniques. So let's begin with model development with PyCard. I use PyCard, an automated machine learning library to streamline model selection and training. PyCard's classification setup handle processing, imputation, and feature scaling automatically. I enabled imbalance fixing mode to address class imbalance. I compared multiple models including LightGBM, random forest, XGBoost, logistic regressions. After model comparison, LightGBM performed the best, achieving a high AUC and improved record. The second one is data processing feature engineering. To improve model input, I applied one-hot encoding for category variables, feature scaling for numerical features, feature creation. This helped to enhance model accuracy and interpretability. The third one is addressing class imbalance. Since strokes are rare in the dataset, I use PyCard's built-in smoke to imbalance classes. Additionally, I tested different resampling techniques manually. So smoking yields the best balance between record and precision. So yes, a fully functioning classifier was built using PyCard and additional tuning techniques. So the second one is, has the performance be being validated? A classifier is only useful if its performance is validated correctly. The first one is validation through PyCard's auto machine learning. PyCard made validation straightforward, like it can compare models, automatically test different classifiers using k-fold cross validation. And for auto-turn-based model, PyCard fine-tune hyperparameters to optimize record and AUC. The final model evaluation is after turning. PyCard provided metrics such as accuracy, record, and confusion matrix. The second part is performance matrix. To fully validate performance, I measure accuracy, record precision, F1 score, and AUC. Since stroke prediction is high risk, record will prioritize over accuracy. The third one is threshold optimization. Instead of using PyCard's default threshold, I fine-tune it manually. I tested thresholds from 0.1 to 0.9, selecting the ones that maximize F1 score and record. So the final best threshold is 0.75, significantly improving stroke case detection. The fourth one is confusion matrix analysis. I examined false positives and false negatives. So the false negatives, which is missed strokes, were reduced to it by adjusting class weights. After turning, record improved from around 28% to 50%, reducing the risk of missing critical cases. Thus, the classifier's performance was appropriately validated using PyCard's automated validation and additional training techniques. The third one is validation strategy, which is k-fold cross validation. To ensure my model was robust and not overfitting, I use k-fold cross validation. Rather than relying on a single train test split, k-fold cross validation divides the dataset into k subsets, trains the models on k1 subsets, and tests it on the remaining fold, which repeats the process of key times averaging results for stability. This prevents overfitting and ensures generalizability. The second one is how was it used? PyCart automatically applies straight-five k-fold crossing validation during model comparison. I manually performed five-fold cross-validation with different resampling techniques to compare results. The final F1 score in AUC confirmed the model consistency across different folds. Thus, cross-validation was successfully used to assess and improve the model's fit, ensuring it performs well on unseen data. So for conclusion, to summarize, a functioning classifier or SPU using PyCart lets GBM and advanced processing. Performance was validated through PyCart's automatic matrix threshold tuning and confusion matrix analysis. A k-fold cross-validation ensures stability and prevents overfitting. This approach leads to a model that maximizes recall while maintaining strong overall performance. Thank you for listening, and I'm happy to take any questions. And for the last part is like key additions with PyCart. So PyCart automatic processing, model selection, and hyperparameter tuning. And AutoML provide built-in validation and comparison across classifiers, and cross-validation was used for model reliability. Thank you so much.